students. Is my voice clear, audible?
Yes, ma'am.
Okay, good. Now, so today's class is about electric potential. Yesterday there was a meeting, so I could not take the class. Okay, so previously we discussed Gauss law, applications of Gauss law. Okay, till now we discussed two important topics in module 1. One is Coulomb's law and another one is Gauss law. Okay, using these two, how to find out electric field intensity for different types of charge distributions. That is what we discussed till now. Okay, and also we did some example problems. Now the next topic is electric potential. What is electric potential? Okay, so consider a region where there is electric field E bar. So it is shown here, arrow marks are shown. Okay, so suppose this one, this line, and this line, and this line. What are these lines? These lines are nothing but electric field lines, flux lines. Okay, so they indicate the electric field direction. Okay, suppose you consider a region. There is a region where there is electric field like this in this direction. Okay, now this point is origin. Okay, this is origin. Now suppose you want to move a positive charge from position A to position B. Okay, from A to B the charge is to be moved, and this is our origin. Okay, and this represents the field. Okay, then the work done. What is the work done in moving this charge from A to B? Okay, for that we write one expression, and see here dw bar is equals to minus f bar dl bar. That is the work done. Okay, but this is not the work done in moving the charge from A to B, because we are considering only what is the displacement here, dl bar. Okay, so suppose L represents the path length from A to B. Okay, the total path length is, suppose L, small l, that is the total length. Okay, now the charge is to be moved along this length L, but consider a very small part of it, means differential length dl. Now the differential work done in moving the charge along this differential length dl is given by this expression, dw bar is equals to minus f bar dl bar. Okay, this represents the work done in moving a unit positive charge along a differential length dl bar. Okay, and where F represents the force acting on that charge. Okay, F represents the force experienced by that charge. Okay, what is the expression for force from Coulomb's law? The force for Coulomb's law is given by QE bar. F is equals to QE. You know this relation. Okay, substitute that QE here. So F bar is equals to QE bar. Now this is, what is this? The differential work done in moving the charge along differential length dl bar. Okay, now suppose if we want the total work done in moving the charge along the total length A to B, then what we have to do? Simply take the integral on both sides. So taking integral on both sides for this expression, okay, what did we get here? W is equals to, this is the total work done, is equals to minus Q. This is constant, so keep it outside the integral, minus Q integral, okay, E bar dot dl bar. This expression is very, very important. Okay, and this gives the energy or work done in moving a charge Q, in moving a charge Q from initial position A to final position B. Okay, so A represents the initial point and B represents the final point. Okay, so from A to B we are moving the charge, and this is the expression. Okay, now from this, what is the next step? Now if we divide this equation on both sides with Q, okay, divide this equation with this charge Q, then it will be W by Q is equals to minus integral A to B E bar dot dl bar, right? Now this W by Q, what does this represents? W by Q represents the electric potential or potential difference between these 2 points. Okay, W by Q, the work done or potential energy. Okay, this represents potential energy per unit charge, unit positive charge we are considering. Okay, so the work done per unit charge in moving it, the particular charge from point A to B is given by this expression. From this we can write the expression for electric potential. Okay, and how? By dividing this expression with Q on both sides. So W by Q represents the electric potential. Okay, since we are representing 2 points here, means we are not taking any 0 or infinity as reference. So clearly A is 1 point and B is another point. So this represents potential difference. Okay, potential difference between these 2 points. Suppose if we take any reference point, then we can replace this with absolute potential. Adi kuda next vastundi, but this represents potential difference, VAB. Meeru circuits lo kuda chadvaru kada, what is VAB, or simply VBE antam. What is VBE? Potential between 2 points, base and emitter. Okay, similarly the potential difference between these 2 points is given by VAB is equals to minus integral A to B E bar dot DL bar. What is E bar? E bar means this field, the field where the charge is moving. And what is DL bar? DL bar represents the differential length. Okay, this represents the differential length and E bar represents the field. Okay, now this is the expression for potential difference. Okay, here observe there is negative sign, negative sign before that integral. Okay, this indicates that the work is done by the field itself. Okay, negative sign represents the work is done by the field itself, means the field is doing the work. The field is moving the charge from one point to another point. If the work is done by some external agent, then here positive sign will come. If VAB is positive, okay, the work that represents the work is done by some external agent, not by the field. Okay, so sign indicates whether work is done by the field or by some external agent. But you remember this expression, this is very very important expression. Potential difference VAB is given by minus integral A to B E bar dot EL bar. Okay, E bar represents the field where the charge is moving, and DL bar represents the path, means displacement. Okay, the path along which the charge is moving. A represents the initial point and B represents final point. Okay, now let us apply this to our practical examples, different charge distributions, etc. Okay, this is general expression. Now suppose this E bar, okay, this field we are considering, that is because of another positive charge which is present here. This is our origin. Okay, we are moving one charge from A to B. Now suppose this electric field is because of a charge Q present here at the origin. Okay, then what is the expression for E bar? Electric field because of this charge at Q. We know the general expression. What is that? Q by 4 pi epsilon naught R square AR bar. Okay, the expression for field, general expression for electric field because of the charge Q at that origin is given by Q by 4 pi epsilon naught R square AR bar. Okay, now substitute this expression here. So VAB is equals to minus integral A to B. Okay, simply we are replacing A and B with position vectors RA and RB, because now we are considering there is another charge here. Okay, and this charge is moving from A to B. Okay, so write the position vectors for points A and B. So this is RA position vector and this is RB, another position vector RB. Okay, so simply replace the limits RA and RB minus integral Q by 4 pi epsilon naught R square AR bar DL bar. Okay, so what is R here? The distance. And what is AR bar? The vector, unit vector along that distance, means along that direction. Okay, now write DL bar in terms of this R. Okay, what is DL bar? DL bar is actually the path where the charge is moving, differential length where the charge is moving. Okay, here we are not using any one type of coordinate, means we are not considering Cartesian or spherical or cylindrical. We are writing general expression only. Okay, so here DL represents the path along which the charge is moving. Suppose the distance moved by the charge is R and the unit vector along the distance means path is ER. Okay, ఈ ఎక్స్ప్రెషన్ మనం ఎలా డిరైవ్ చేసామో గుర్తు తెచ్చుకోండి. ప్లీజ్ యూ వన్స్ రికలెక్ట్ హౌ వి డిరైవ్ దిస్ వన్. ఆర్ రిప్రజెంట్స్ the distance, okay, center of the sphere to that point where you are measuring the field, that is this r, and ar bar is a unit vector along that direction, right? So we are writing this dl bar in terms of this r only. We are not using one more variable. Already r is there, okay? So అందుకు dl ని మనం r లో రాస్తున్నాం. అంతేగాని డోంట్ కన్ఫ్యూజ్ విత్ స్పెరికల్ కోఆర్డినేట్స్. dl ని r లో రాస్తున్నాము అంటే స్పెరికల్ కోఆర్డినేట్ సిస్టమ్ లో ఎక్స్ప్రెస్ చేస్తున్నట్టు కాదు. Okay, clear? Here we are writing, expressing this dl in terms of r only, because already we defined this e bar in terms of r. అందుకు మనం యూనిఫార్మిటీ కోసం we are replacing this dl with r. Okay, so dl ఏమవుతుంది అప్పుడు? dl will be equal to dr ar bar. Okay, dl will be equal to dr ar bar, differential distance or differential length, and ar bar represents the unit vector in that direction. Okay, so replace dl with dr ar bar. Now this is the equation. VAB is equals to minus integral RA to RB q by 4 pi epsilon naught r square ar bar. Now replace this dl with dr ar bar. Okay, so ar bar dot ar bar means 1. Now we have integral RA to RB q by 4 pi epsilon naught r square dr. This is simple integration problem. So q by 4 pi epsilon naught, you bring it outside the integral. So you will be left with integral RA to RB. So this is A, RA, and this is B. Okay, RA to RB, we have 1 by r square here. 1 by r square. This is r not b. 1 by r square dr. So you know what is integral of 1 by r square? R power minus 2 plus 1 by minus 2 plus 1 ante minus 1 by r. Okay, so minus 1 by r integral a to b. Okay, substitute the limits. Okay, so this is nothing but here one negative sign is there before this integral, and this negative sign and this negative sign will become now positive. So what is the final expression we got here? Q by 4 pi epsilon naught into q by 4 pi epsilon naught into 1 by, this is you substitute the limits, 1 by rb minus 1 by ra. Okay, 1 by rb minus 1 by ra. This is the expression for potential difference. Okay, the potential difference between 2 points A and B. Okay, what are the 2 points? Those are the 2 points between which the charge is moving along a line. Okay, and that too within an electric field. There is a electrostatic field region, and in that region the charge is moving from initial position to A and final position B. Then the potential difference between those 2 points is given by VAB is equals to q by 4 pi epsilon naught into 1 by RB minus RA, 1 by RA. Okay, this is the expression. Now this is further written as how VB minus VA. What is VB? Q by 4 pi epsilon naught RB means you multiply this constant. Okay, then you will get q by 4 pi epsilon naught RB minus q by 4 pi epsilon naught RA. Okay, so this q by 4 pi epsilon naught into R in general, we are not considering DRA, is nothing but potential, expression for potential. Okay, since that is measured at point B, it is represented with the suffix B. So this is VB minus VA. So VAB is equals to VB minus VA. Okay, now suppose here initial point is A. So suppose that the initial point is at infinity, means the charge is moving from some infinite distance to some point B. That is the meaning, right? This is initial position and this is final position. Now suppose the charge is moving from infinity position to say point B. Okay, so this is our example, right? Now assume this A is at infinite distance. This is our origin. This is point B. Now A is extended to infinity. So RA will become infinity, right? RA means the distance vector joining that infinity point to 0. So it will become infinity. So RA is infinity now. Now substitute that RA here. When you substitute RA is equals to infinity, this will become 0. Okay, 1 by infinity is 0. So now we have VAB is equals to VB minus 0, which is nothing but VB only. ఇది ఎప్పుడు ఇది only when we treat the initial position at infinite distance. Okay, when the charge is moved from infinity to a point B, this is the case. So now VAB reduces to absolute potential at VB only. What happened to the potential at A? What is the potential at A? 0. Okay, when the point is moving from infinite distance to a particular point B, what is that potential at infinite distance? 0. VA is equals to 0. Potential at that reference point. Ippudu nenu reference point and now I am using the term reference point. Okay, infinity distance nunchi we are moving it to say point B. Okay, ippudu aa infinity distance, that point is now considered as a reference point. What is the potential at reference point now? 0. So that means you are moving the charge from a reference point, and at that reference point, what is the potential? 0. The initial value potential is 0. From there, you are moving the charge to another point B. Okay, now treat this B, any point, any general point. Let us generalize this. Okay, RB tends to R means, now what is RB? RB represents the distance vector, the distance between origin and this point B. Now this is not B. You suppose any general distance R. Okay, any point. This is another any point. Okay, now what is that point distance from origin? R. Assume R. Smaller represents the distance of any point considered here from the origin. Okay, let it be R. Then the general expression for potential now becomes V is equals to Q by 4 pi epsilon naught R. Clear? Infinity is A and B is any point. Okay, so you are moving the point from infinity to a point which is a distance R from the origin, smaller units from the origin. Then what is the potential? The potential at that distance smaller means at point B. మీకు క్లియర్టీగా ఉండడానికి again I am using B. B is a distance R units now. Okay, don't use RB అనకండి, ఎందుకు we are trying to generalize the problem. Okay, so that point B is a distance R units. B అనేది ఏ పాయింట్ అయినా అవ్వచ్చు. You take any point in that region. Electrostatic field region lo you take any point. Okay, and that point is a distance R units from the origin. Okay, now the potential at that point is now given by V is equals to Q by 4 pi epsilon naught R. And is it a vector quantity potential? No, remember electric potential is a scalar quantity. Unlike force and E bar, electric field intensity, electric flux density, electric potential is a scalar quantity, V. Okay, what is the importance of this potential? Why we are studying this potential? Okay, that we'll see. So this is the general expression for potential at point V, point R, which is at R units from the origin. Clear? In a coordinate system, the potential which is at a distance R units, that point is given by, the potential at that point is given by Q by 4 pi epsilon naught R. Okay, and see here one important point is written, VAB is independent of the path. What is the meaning of this statement? VAB is independent of the path. Suppose earlier we considered that this is say our origin O and this is A and this is say point B. Okay, now the path taken by the charge is this. This is what we assumed initially. Okay, so when the charge is moving along this path A to B, what is the potential difference between these 2 points? Okay, that we have written, and this is the direction of field, for example. Electric field. So this is what we assume. Now read this statement. VAB is independent of the path. What is the meaning of this point? Suppose there is another path like this. VAB. There is another path. VAB. There is another path. VAB. Whatever may be the path. Either suppose I am numbering them. Numbering these paths 1, 2, 3, 4. So either path 1 or path 2 or 3 or 4. Whatever may be the path. Okay, always the potential will be same. This is independent of the path taken. Clear? Independent of the path means whether you are moving the charge in path 1 or along path 2 or path 3 or path 4, whatever may be the path taken, that but the potential difference between the 2 points remain the same. Okay, VAB is independent of the path. That is the meaning. Okay, so this is potential. Now he is giving the general definition of this potential. What is potential? Potential at any point is the potential difference between the point and a chosen reference point at which potential is zero. Okay, the potential at any one point. So suppose B, you think of that B, the potential at B. What is potential at B? The potential difference between the point and a VB and a chosen reference point at which potential is zero. మనం దీన్ని ఏమని assume చేసుకుందాం? We assume this as VA. Okay, so potential difference between the point B and the reference point A, VB minus VA. But what is VA? Zero. The reference point at which potential is zero అనుకుంటున్నాం. Okay, so the point, reference point అంటే ఏంటి? Which point is to be treated as reference point? The point where potential is zero. Okay, that is the reference point. Yes, mute. Okay, so this is potential, definition of potential, the difference between 2 points, potential difference between 2 points. This is the assumed point B and the reference point A where the potential is zero. Okay, so general definition of potential is the potential difference between the point where we are measuring and a reference point where the potential is zero. That is defined as potential. Okay, so simply substitute those two limits here. A to B, V, what is V? V is nothing but minus integral A to B E bar dl bar. In previous expression, you take this previous expression, V is equals to minus integral A to B E bar dot dl bar. You take that expression and substitute the limits. So A is infinity, B is R. The point B is at R units from the horizon. Okay, so minus integral infinity to R E bar dot dl bar. Okay, this is V when you substitute the limits. Now, if the point charge is not located at origin, so till now we are assuming that the point charge, where is the point charge located? At origin. This field is because of charge located at origin. That is what we are assuming till now. Now suppose that charge is not located at the origin, it is somewhere else. ఇంకొక point ఎక్కడ ఉంది. Suppose some C here. Okay, and suppose this C, the vector means distance vector joining origin and this point is say R bar. Clear? The field is because of the charge which is not at origin but say at some point C. And what is the distance between this point and the origin? The position vector is given by C bar. If this is the case, then how the expression will change? That is given here. See, V of R. Now it is a function of R. Previously we wrote V because we assumed that the charge is at origin. Now this is a function of that R. V of R is equals to Q by 4 pi epsilon naught modulus of R minus R bar. See, ikkada R antunna, what is this R? This is distance only. Okay, even if it is a vector, because the position vector, we have to take the mod value. Adi meeku telusu. Okay, you all know that. Now Q by 4 pi epsilon naught R minus R bar. This is the expression for potential when the charge is not at origin but at some other point which is a distance R bar from the origin. Okay, Q by 4 pi epsilon naught R minus R bar. Okay, this is for one charge. Suppose if there are n number of charges. Try to join the meeting within 10 minutes from the beginning of the class. 10:20 ki class start అవుతుందంటే please try to join the meeting by 10:30. 10:30 తర్వాత maximum join అవ్వకండి. ఓకే, మీరు జాయిన్ అవుతూ ఉంటే నాకు డిస్టర్బెన్స్, వింటున్న వాళ్ళకి కూడా డిస్టర్బెన్స్. ఓకే, ప్లీజ్ ట్రై టు జాయిన్ అట్లీస్ట్ వితిన్ 5 or 10 minutes at least. Okay, after beginning of the class. Now So this is for one charge. Now suppose there are n point charges. Okay. So in our previous problem, we suppose that there is only one charge here. Now suppose there are n charges. Okay. At C, we have one charge, and that is a distance say R1, and there is another charge at D. Suppose this is some Q1 and this is at Q2. Okay, there are number of charges, and what are the position vectors? Corresponding position vectors are R1, R2, R3, so on. Okay, but we want the potential at this point only, which is a distance R units from the origin. Okay, now because of these n number of charges, what is the total potential? Okay, again, it will be the superposition of all the individual potentials. Okay, so the expression is containing summation. Okay, superposition of individual potentials. So Qi, see now there is Qi because now we are not considering single charge. Okay, there are n number of charges which are at different distances from the origin. So Q1 is at distance R1, Q2 is at distance R2 from the origin, Q3 is at distance R3, and so on. Okay, now there are n number of charges. Okay, so because of this, what is the total potential? V is now given by 1 by 4 pi epsilon sigma r runs from 1 to n Qi by modulus of r minus Ri. Okay, simply replace this single charge with Qi. Now use suffix I because there are n number of charges, and earlier there was only one charge at distance r bar. Now there are multiple charges at distance r1, r2, r3, so on, rn. Okay, so replace that r also with ri suffix I. Okay, I is running variable. Okay, R is running, I is running variable, I is running from 1 to n. Okay, so the expression is 1 by 4 pi epsilon naught sigma I runs from 1 to n Qi by modulus of r minus Ri. This is for n number of charges, and suppose if the charge distribution considered is not single point charge. Okay, here we are considering point charges. Earlier we assumed that the point charge is at origin. Because of this, okay, the field is there, E bar is because of unit point charge at origin. Later we assumed that the charge is not at origin but at some point r dash units from the origin. Again, that is point charge only, but it is not at origin, so r bar units. Later we assumed that this entire field is because of n number of charges. Okay, n number of point charges located at various distances. Now what is the next step? Point charge distribution is over. Now next we have to extend this concept to different other charge distributions. What are the other charge distributions? Line charge, surface charge, and volume charge. Okay, these are symmetric charge distributions, we know. Okay, so now assume that this field is because of a line charge. Similarly, the field is because of surface charge. The field is because of volume charge. Okay, further, how the expression will be modified now? Let us see. Okay, now the potential V is now given by, see, V is now given by 1 by 4 pi epsilon in place of this Q. Okay, previously this Q is a point charge. Now this is a line charge. So this should be replaced with, dento replace chestaru, line integral rho L dl. Okay, line integral rho L dl, because this is a function of r bar. R bar represents the distance. Okay, so rho L of r bar dl bar, or simply we can say rho L dl if we ignore this r, that this is a function of r. Okay, so rho L dl bar. Similarly, if we say that the charge distribution considered is surface charge, then Q has to be replaced with surface integral rho S ds. Similarly, for volume charge, Q should be replaced with volume integral rho V dV. Okay, then the modified expressions will be like this. And see, for this prime means bar is indicated here, r bar, ds bar, and here also r bar, but this is without suffix. So what is means the parameter with suffix is what, and without that r bar means prime is what, that he is giving the clarification. Primed coordinates denote source point. Okay, unprimed coordinates refer to field point. Ante what is the meaning? Potential man ekkada measure chestunam, we are measuring a distance r. Okay, one particular point we are measuring the potential at particular point r, which is at distance r units from the origin. Okay, so ekkadaithe measure chestunamo, number of times మనం discuss chesam previously. Okay, the point where we are measuring a certain quantity, either e bar or d bar or here now v. Okay, a point of measurement name antam field point. So ఇది field point. Okay, and all these represents source points. Okay, source charge distribution point అనకూడదు, ఎందుకు ఇక్కడ we are considering continuous distribution. Line charge, it is a continuous distribution. Surface charge, అది కూడా continuous quantity. Volume charge, అది కూడా continuous quantity. Okay, so source distributions ఇవంతా కూడా source points, and ఇది this represents field point. So primed coordinate represents, they correspond to source charge distribution. ikkadaithe line charge, ikkadaithe source charge, ikkadaithe volume charge. Unprimed coordinates ante here r, ఈ r represent the point where the potential is measured. Clear? So this is potential. There is a problem on this. Now I am repeating again this topic. అంటే ఒకేలా ఉన్నాయి డెరివేషన్స్, కన్ఫ్యూజింగ్ గా ఉంది. ఎస్, కన్ఫ్యూజింగ్ గా ఉంటుందమ్మా, కొంచెం అర్థం చేసుకోవడానికి ట్రై చేయండి. అందుకే మీరు కూడా చదవండి. క్లాస్ లో నేను చెప్తున్నప్పుడు ఏదో నేను ఒకసారి చెప్తాను, ఆ 2-3
వాడు పడితే వీడు, వీడు పడితే వాడు.
ఎస్, ఏదో చెప్తున్నారు, స్పీక్ అవుట్. All derivations will be similar. Okay, అన్ని డెరివేషన్స్ కి సిమిలారిటీ అనేది ఉంటుంది. Okay, but we have to practice them and remember them. E bar, d bar, and now potential. Okay, all definitions will be similar, ma. I agree with you. See, e type of disturbance is not actually acceptable. Whoever is making this, please stop doing this. You are creating disturbance to remaining class also. If you are not interested, you please don't join. జాయిన్ అవ్వకండి. ఎవరు మిమ్మల్ని ఫోర్స్ చేయట్లేదు కదా, జాయిన్ అవ్వండి, క్లాస్ వినండి అని. ఇంట్రెస్ట్ లేదు. Okay, so please don't repeat this. డెరివేషన్స్ అన్ని సిమిలర్ గా ఉంటాయమ్మా, ప్రాక్టీస్ చేయాలి. బట్ మీరు నెంబర్ ఆఫ్ టైమ్స్ చదువుతూ ఉంటేనే గుర్తుంటుంది, లేకపోతే గ్యారంటీగా మర్చిపోతారు. ఓకే, ప్రాక్టీస్ అనేది చాలా ఇంపార్టెంట్. ఈఎండబ్ల్యూటీ సబ్జెక్ట్ కి మీరు డెరివేషన్స్ నెంబర్ ఆఫ్ టైమ్స్ ప్రాక్టీస్ చేస్తూనే ఉండాలి. ఓకే, నౌ సో ఇంతవరకు we revised mostly 3 topics. అంటే law may be different, but mostly we considered how to find out E bar. First, electric field intensity ఎలా కంప్యూట్ చేయాలనేది డిస్కస్ చేసాం. ఫ్రమ్ దట్ D bar. Okay, first E bar, then followed by D bar. Now we are extending the concept to V, potential వరకు వచ్చాం. Okay, so potential కూడా సేమ్ డిఫరెంట్ చార్జ్ డిస్ట్రిబ్యూషన్స్ కి ఎలా ఫైండ్ అవుట్ చేయాలి, వాట్ ఈస్ ద ఎక్స్ప్రెషన్. Okay, V for point charge, V for line, surface and volume charge. అవి 3 expressions ఇప్పుడు నేను చెప్పాను. Okay, first let me revise this topic, today's topic. Okay, ఈ రోజు డిస్కస్ చేసింది మళ్ళీ నేను ఎక్స్ప్లెయిన్ చేస్తాను. ఓకే, దెన్ యూ గో త్రూ ద రిమైనింగ్ టాపిక్స్, ప్రీవియస్ టాపిక్స్ కూడా ఒకసారి చదవండి. అప్పుడు రేపు విల్ డ్రైవ్ వన్ కన్క్లూజన్, ఏంటి మనం చదివాము, ఎందుకు కన్ఫ్యూజన్ వస్తుంది అనేది డిస్కస్ చేయొచ్చు. ఓకే, సో ఈ రోజు టాపిక్, టుడేస్ టాపిక్ ఈస్ ఎలక్ట్రిక్ పొటెన్షియల్. Okay, so potential. First of all, start with derivation starts with work done, potential energy required to move a charge, unit positive charge from point A to point B. Okay, so E bar represents the field, electrostatic field. So there is a field, electrostatic field in that region, field region. What is the energy required or work done in moving the charge from point A to B? Okay, that is what we are discussing now. Wait 1 minute. There is a problem with my laptop. Screen is not visible to me. My screen. Okay. Complete the screen off. I think there is a problem. Now it's okay. Okay. So till now we discussed this point, electric potential. Okay, we have started electric potential. So field, there is a field E bar. Now in that field region, a charge is to be moved from position A to position B. Okay, so first, what is the work required or energy required, potential energy required for moving that? For that, expression is given, W is equals to minus Q integral A to B E bar dot DL bar. That is the expression. Okay, now from that, try to find out what is potential. If you divide that with Q on both sides, the potential energy required per unit charge or work done per unit charge is nothing but the potential difference between the 2 points A and B, source point and final point, destination point. Okay, so VAB is given by minus integral A to B E bar dot DL